Hi guys, welcome to another in the preliminary chemistry video series. This one is going to look at the nomenclature of inorganic molecules. We previously have looked at how we name ionic salts, so inorganic salts that are formed between two ions, cations and anions. But we also have a very significant number of molecules and compounds that we will need to study that are a combination of covalent bonded atoms. And the way that these are named also has a series of rules that can get quite complex. So we'll try and simplify it now, and then we'll expand as we go through the course. So the first thing that's important to remember is that when non-metals combine together, they don't form ions. This is because ions are formed between when atoms gain or when they lose electrons. Gain or lose electrons. Now this is fine when you have species which want to lose electrons like metals, but when two species both wish to gain electrons, then we have a bit of a problem. In fact, what happens is instead of one species gaining and one species losing, they both share the electrons. And because of this shared arrangement creates covalent bonds. Now these can form discrete molecules such as carbon dioxide, or they can form complex networks such as is created in diamond between carbon atoms. The other thing that's important to remember is that covalent molecules can exist in more than one form for the same two elements. So here we have two compounds formed by the combination of sulfur and oxygen. And so our naming systems are going to need to take into account these differences in the ratios of sulfur and oxygen in this case. You're probably already aware that the fact that the first element is always named in full. So just as we did with, say, magnesium oxide, we would call this sulfur oxide. The oxygen changes to the "ide" ending, but this time we have to have some understanding of the difference between the 2 and the 3. So these are prefixes that we use in order to indicate how many oxygens there are. Di meaning 2 and tri meaning 3. These are derived from Greek, from the Greek language, and these prefixes are used to indicate the numbers of atoms in each molecule. Now from about 5 on, penta, hexa, hepta, and so on are pretty consistent, but it's the first few that may be less familiar to you. So we, for example, name this compound carbon monoxide. We have an example of the dis and the tris in sulfur dioxide and sulfur trioxide when we have 2 and 3 oxygens respectively. And something like this might be named carbon tetrachloride, tetra meaning 4. So a few other things. Firstly, the element with the lower group number is named first. So noble gases are out on the end, 8 or 18, depending on which numbering system that you use, and they are stable, so they don't form compounds. So going back from there to the halogens, so fluorine, chlorine, and so on, these have higher group numbers and they're regularly named second. But of course, one of the things you'll realize the more chemistry you do is how many exceptions there are to the rules. So we'll try and look at the rules and then deal with some of the exceptions later on. The Greek prefix specifies the number of atoms of each element. So for reasons of economy, often the mono isn't identified. And we only use that number to indicate more than one. The IDE is the same rule as we use for the ionic salts when we have 2 elements, and I guess importantly there are certain types of compounds which you could name a certain way but which actually have more common names. Everyone knows the formula for water is H2O, but we don't call it dihydrogen oxide or dihydrogen monoxide. We simply call it water because that's its common name. And things like ammonia and methane, likewise, are more often known by these common names. So, a couple of examples. for us to quickly have a look at. You can stop the video here if you want and see if you can name these yourself and then double check. But otherwise, I'll go through them with you. So the first one would be di-2-nitrogen because it's named first. Oxide. We could call it monoxide, but it's just as easy to drop it in this case. The second one is di-nitrogen. Tetroxide. Tetroxide, meaning 4 oxygens. This one is carbon monoxide, and I guess one of the most common compounds of carbon and oxygen is carbon dioxide, so the monoxide is actually used in this case. This one is methane, which you could call carbon tetrahydride, 4 hydrogens, but methane is the common name, and likewise this one is known as ammonia, IA, but could be regarded as nitrogen trihydride. I hope you did okay. Thanks for watching.